All right. Good morning, everyone. I guess as good as any time to start, so let's get started. Certainly welcome everyone this morning. I know last evening was very fun at Stack City, probably too fun, so. Now let's start talking about Telco Cloud requirements. Before we really get into the specifics of VNFs and what they need, I want to make sure we have level set on the basics so there's no confusion. As is always with telcos, there's acronyms galore, so I apologize ahead of time. VNFs, the phrase VNF in particular, virtual network function, whoever came up with network function virtualization didn't really think through that very well. Now we have to have a reverse of it. But anyways, today we're going to introduce some of the, we're going to go through the Telco Cloud and what it is and what we're trying to achieve. And then we're going to talk specifically about the requirements that we're seeing and then possibly and get into some of the future things that we anticipate. As we get into this, I want to level set on what we're up to. It's very easy to get lost as we go forward and go through this process to get very focused on cost and solely on cost. So certainly when we talk about commodity boxes and running routers, virtual routers on open source and making the transition to virtualization, most of what you think of is all about, okay, they're trying to drive the cost down. As we heard on Monday from Saurabh, our network traffic is going up 150,000%. It's going to keep going up and up. And we have to respond, in as most optimal capital spend as possible. So that's certainly a big part of it. But we can't be lost on that and only on that. Certainly there's the operational aspect and making things more automated and such. But it has to be more than that. Otherwise it's just a commodity. We're just making bits into corn. We have to add more value. We have to find ways to add more to what we're doing. And this is where the cloud is an essential ingredient to that, adding value. So over time, we've expanded and we've done a pretty good job this way, and I think you see that represented most significantly in the last year with our acquisition of DirecTV. That move has helped us in enormous ways, beyond just adding more content and adding more services and more of a footprint. That's all good, but it's also added a group of people that have been very innovative when it came to the presentation layer, the content management, the content agreements. There are aspects behind the scenes that are unique. In the next period of time, we're going to take advantage of this cloud that we're working on now to make it into something, make the next generation DirecTV Uverse combination into something really unique. So add more value to it. And we're going to take advantage of the ability to spin up new services and new instances of the content management system and the way that we work. We're going to do that far faster than we ever did before. So that's one part of what we're talking about that I don't want to get lost on. And then when we think about the whole process that we're working on, and we've talked about this in the ITIL world forever, that front end of service definition and making that much faster is as much a part of automation as the rest of it. So that's what I wanted to make sure we level set on first.
Just to add to what Toby said, personally in my view, the nirvana will ultimately be when Amazon starts using these clouds to spin up workloads. Ultimately, because there is a tremendous amount of value in the assets and physical distribution that a lot of these telcos already have. So there's a tremendous amount of value that's underestimated, I think, in optimizing that last mile connectivity for a lot of these over-the-top players. And one thing I would add, it's more than just infrastructure optimization, and for telcos to add new value-added services, I think one of the key components is really opening that environment up for anyone to spin up new services. Because they're probably going to be a lot more agile and have the ability to spin up creative services and enhance the value to their customers as a result. Oh, I want to talk to that. So if you kind of look at, I mean, what telcos do, they're predominantly have done connectivity for the last 100 years in different forms. IP, in a lot of ways, has been commoditized, and that's just a reflection of building an industry that pretty much has transformed the world. So really the next step is, how do I start thinking beyond just IP services or connectivity and really leveraging what I call the beachfront properties that a lot of these telcos have. So if you just look at some of the key properties of what a telco cloud target architecture is, and there's definitely a lot of different components to it, but I'm just focusing at this point on connectivity, is physical distribution. I mean, that's a given. These are the things the web services guys are just dying to have, right? If you just look at what they're doing physically, they're trying to expand their networks and their data centers closer and closer to as much eyeballs as possible. So that's one key component of a telco cloud. And of course, that enables the workloads to have low latency, high availability through distribution. That's natural as a result. High volume of last mile throughput. That's just a nice way of saying, if Netflix wanted to start offering me, House of Cards with 4K streaming, and I'm willing to pay for that, Netflix can actually optimize that without having to grow their peering points into AT&T's networks, and AT&T doesn't have to carry all that traffic in their network. I call it almost like CDN on demand or something. I mean, I'm not a marketing guy, but that's kind of the intent. You can optimize your network, not for peak, but while enhancing the experience. So, and then I think the last property, of course, is telcos have built a very large network. I mean, they've billions and billions of dollars in the last decade, two decades, really building out this massive infrastructure. So you can't get lost in the fact that there's this existing environment. You have to make the transition for the telcos a lot seamless or a lot easier into the cloud world. So leveraging the existing technologies that they already have deployed and operationalized around not only makes it an easy technology shift, but it actually helps a lot. And I've seen it in a lot of different telcos, the discussion a lot easier for a lot of these traditional networking and telco guys to start thinking about cloud, because there's a comfort level to it. So,
yeah, so just to add to that point is a bit, one of the problems that Marco and I spend a lot of time working on is this taking a packet and bringing it from the VM that we set up or the container and bringing it to our user, or bring it from one VM to another. That pathway from the VM out of the building to another building, that has to be somewhat optimized. We can't be encapsulating it one way here, adding another layer of encapsulation there. We have to think about the whole end-to-end to make this work. And this is one of the reasons why the work that we're doing I think is helping, is taking that and solving for latency and jitter issues by reducing the overhead across the whole of data center and WAN.
So before people start freaking out because they see BGP and MPLS, I mean, this probably makes a lot of sense for network and telco guys. But I think at the end of the day, what I'm trying to capture here is the building blocks that have been used to build networks for the last 20 years or so. Looking at building blocks and how large data centers and fabrics have evolved over time. If you can just build that out. You have the data center fabrics. All these combined, ultimately, a lot of complexity involved, a lot of details to build really large and distributed networks, which in a lot of ways, that's what the internet is. It's a large distributed network. Therefore, how do you kind of bring that into the cloud environment, particularly OpenStack? And being able to abstract a lot of this ultimately to just common APIs, and in this case, Neutron, is kind of the key value of how you bring OpenStack into this whole telco cloud environment and kind of, merging the two worlds together. And if you kind of build it, so it's kind of the idea.
OpenStack everywhere.
Yes, it took me about 2 minutes to build all that out. Got to be a better way to do that. So yeah, the idea ultimately is you have this physical network, and at the end of the day, you just workload placement, whether it's containers, VMs, or even bare metal. I think bare metal or hosting as a service is probably a very attractive option for a lot of these over-the-top players as well. So the point is, enhance the value by allowing these cloud workloads to be spun up close to your eyeballs. And one key thing for the telcos to realize is that actually gives an incentive for people to want to stay on their network. right? If me as a gamer can pay an extra $1 a month to some gaming company because it reduces my latency by 5 seconds, so I have a better chance of fragging someone while I'm playing online, I'm willing to stay on AT&T's network while at the same time paying this gaming company an extra $1 a month, right? And they can monetize that as well. And that goes back to the whole new value revenue type stream thing.
Yeah, so when we talk about VNFs and the VNFs, when we tell you network function, this is a pretty good representation of when I think of VNFs, this is what I'm talking about. So it's more than just the L3, L7 stack of routers, firewalls, NATing. That's definitely a part of it, but it has to be more than that. Certainly all the security aspects that come with well beyond firewalls and IPS, it has to be much more than that. In the telco world, voice is a big part. It's a lot of our focus, but the reality of voice is that it is just one of a billion applications at this time. So we want to make it very good, but then we want to move on and find ways to bundle it or work with putting it into other contexts and other services. As you can imagine, having closeness to a user in the old web paradigm where the data came from some center and is distributed out in the TV model where we take content from one place and move it everywhere, caching is an essential ingredient. But we also have to realize that with IoT, that that whole dynamic is flipping itself around. That now the data is coming from everywhere. And if you just think of one simple example, like a connected car having dash cams front and back with 4K video, which is not out of the question, especially for insurance folks, they want to see that kind of information. That amount of data coming into the cloud and being at the edge needs to be stored, needs to be processed. So something's going to have to happen there to change that dynamic. So that's an example of a VNF that is changing the way that we're thinking about, and another reason why we're putting these open stacks everywhere. The last few bits, the last mile, as Mark was saying, the beachfront property that we have, we're trying to innovate there and make it much easier and lower cost to bring fiber to your house. And so a lot of the work you see us do with Cord and with Onos around our like Volti and our next generation GPON work is all about that. And then the last bit, as I mentioned, as we evolve our content management, DirecTV, Uverse platforms, that's going to be an integral part of it. Moving and taking that movie that you're watching and putting it into a form that any device can see.
You can build it out if you want. I mean, just based on that, what we know, right? Based on workloads today, right? It's akin to web applications, back-end databases applications, PCRF, packet forming manipulation. It's pretty obvious for a VNF. In some form or another, we got to manipulate a packet. Combination of traditional networking elements, whether it's SBC, load balancing, SIP, UAs, or not UAs, back-to-back user agents, things like CDN proxies and transformation elements are some of kind of what we know from a VNF requirement point of view. But if you build this out next, what you'll see is we're trying to categorize common cloud and VNF requirements. What we see based on the requirements for a lot of these different VNFs, which do overlap with traditional cloud native applications and also VNFs that are coming from the telco world. But we do see obviously a very unique set of requirements coming from the VNFs as well. And I don't know if you want to talk to specifics there, Toby, but...
Yeah, so a key part to telcos want to believe that we're special, but in reality, many of the requirements that we're seeing from the VNFs I described are very similar to what we've had to deal with in the IT world. And I come from a hosting background, outsourced applications delivered over the internet. And in that realm, when you talk about SLAs, with a financial company or a government company, there's times when we've written contracts that have hundreds of SLAs in it. When you look at the latency requirements of a financial company or the jitter requirements of gaming, as Marco was getting at, that's pretty significant and close to what is needed in the telco realm. So this is an important point that we're trying to make, is that a lot of the problems and the requirements are very similar to ones that have been solved in the cloud world already. And then that helps us to clarify where we have actually unique needs. So, when it comes to the common parts of it, the security and the resiliency and no one wants to see anything go down. There's no one that doesn't want 100% availability. When it comes to being able to automate everything, and our orchestration needs are not something unique. Is not something special to a telco's orchestration or monitoring. The world of the ITSMs and ITILs is very similar, almost exactly the same as the FCAPS world and the OSS world. There is almost no difference. And so that's one of the things that I think that OpenStack community is very important about in helping, is to solve for this common set of requirements. Now, where we have uniqueness is certainly when it comes to moving lots of packets and trying to do that in a way that's stable and resilient.
I mean, I was going to say those seem obvious, at least to me, because I've been living this for 3 years. But there are just certain things that make VNFs somewhat unique compared to traditional cloud-native workloads, and that's mainly given the history of the VNFs themselves, right? They've just always lived as functions in the network, PNFs, physical network functions. So a lot of that is a requirement as they transition to the virtual world. But as you'll see later, I believe that's more a facilitation of enabling the brownfield migration for the very reluctant PNF vendors out there, and we'll get into that more detail. We'll get into that in more detail.
So as we go through this, these are some of the high-level methods that we're using to solve for these unique requirements. And the one that's top of mind is getting more packets per second and lower latency and lower jitter and more flows through a x86 server. And that's what I like to say is to SRIV or not to SRIV.
I vote not. But I think it's a necessity at this point.
And then working with the PNF vendors, the folks that have made them, and getting them to learn more about cloud-native mechanisms, especially about horizontal scaling. I think you've heard the pets versus cattle analogy, the one I like to call pets versus midget cattle. Driving toward cloud-native is more than that. It's a lot more about automation and configuration management and an acceptance of maybe even not having a command line to log into your router. These are examples of the kind of change that cloud native has brought to this to the general space. Also, when it comes to what we're working on, we don't live in a greenfield world. We have a lot of the old stuff and the legacy. And so we have to be mindful of that as we bring things forward and continue to support mechanisms that help to support things that aren't cloud native. So mechanisms like live migration or vMotion, these are things that people have used as crutches in the past to help get over the lack of scaling. And so that's something that we have to continue to support going forward. And then thankfully we can use it for other things like bin packing. And then the last bit is, I don't think we've done a good enough job at really communicating especially around networking, what we want and what we want to do. And that's something that we've talked about a lot this week, is just the onus is on us to make it much clearer what we're asking for. So I'll talk this particular slide. We've been spending a lot of effort and testing on trying to figure out for really underneath this, there's a lot of, each of these lines represents a different VNF and their specific needs. And we spent a lot of time working, especially Marco and I, have been working on trying to test and be able to achieve this level of performance through our systems. And we've learned a lot. And then what I'm hoping to do in the near future is to create some level of standardization on how to test and benchmark. Because when it comes to this type of packets per second or flows through a box, there's a lot of variables involved. and trying to standardize that and normalize that, make it something that's easy for the vendors and for us to test in a consistent way so we can compare the answers easily. That's been a lot harder than you can imagine.
So I'll speak to this slide. So pretty much based on essentially the SRIV requirements. I mean, there's a couple of ways you can look at how you address some of the needs that are coming from these VNF vendors requiring SRIOV. So clearly, the obvious answer is go build a cloud-native VNF. And personally, for me, I'm sure some BU folks will be watching this YouTube video at some point. It's a message for them as well. Is if you can't build a cloud-native app, a really fundamental question of should you really be virtualizing that app should be asked of yourself. And if the answer to that is yes, then you really have to put an effort to rewrite that application so it is cloud native. And if the answer is it can't be, then maybe the real answer or solution to that problem is automation. You really probably have to automate it in a way that actually solves the real problem. Because virtualizing something doesn't automatically make it automated, especially if the economics aren't there. Of course, a second option to that is judicious use of SRIOV and traditional cloud workloads. So what we mean by that is, all right, we'll drag you along kicking and streaming. You have your traditional PNF function. You've slapped it in a container or a VM, and now you're saying you're virtualized or you're cloud enabled. That's kind of a I was going to use a word there, but that's kind of the wrong answer, right? I mean, I get it. There's probably some things that you just can't avoid relative to finding the right people. It takes a lot of time, a lot of investment, but the barrier to entry, you should remind these vendors that the barrier to entry is not removed. So while we're reluctantly bringing you in and you're telling me I need SRIOV for these level of high performance, other vendors now can come in and really differentiate with cloud-native based solutions. But up until now, there are options to coexist these kind of workloads with cloud-native workloads. Moore's Law, I don't know if you want to talk to that, Toby, or...
Yeah, so there's a number of options available to us. And what I think is that in this particular area, when you look at enterprise workloads, there was a lull from like 1995 to 2005 where there wasn't a whole lot of innovation happening in this space. It was VLANs and we're happy. It was 1 gig interfaces, we're happy. Now that we're pushing more on this, both us and the hyperscale guys are pushing on this area, the demand is driving innovation to happen. And the Moore's Law needs more things to work on. So doing offloading of certain functions makes sense. So instead of, for me, it's an extreme. SRV is at one extreme where we decided we gave up, we couldn't do anything in software, and we just used hardware to solve the problem entirely. That doesn't give us the extensibility or the software benefits. If we go all software, we can't make it work quite yet. So right now there is, we think, a middle ground where we have like smart NICs, more sophisticated evolution of the existing NICs from the Intels and Broadcoms and such. But then there's also there's a new realm of smart NICs. If you looked at what Microsoft's provided with Sonic or what others have tried, Metronomes and others, we are able to offload some of the standard packet processing functions and put them into an FPGA or a GPU. And that, we think, is actually one of the ways that we can kind of meet in the middle.
I can take this one. I mean, at the end of the day, it kind of hits at the point that the industry has built truly scaled out infrastructure like the internet. I mean, it's the basis of pretty much anything we do in our daily lives now. So, the buzzword is scaled out routing. The reality to me is, in my mind, given my background, that's called BGP. And of course, naturally, as a result, a scaled out platform should look similar but not identical, right? So again, you don't want to reinvent a lot of the tools that have already been used to solve a lot of these very large network problems, and you just kind of want to bridge the two worlds together. And an example of a scale-out platform is pretty much this, right? You want to get a sense of what problems you're solving in the cloud and leverage as much of the tools that already exist out there to solve those key problems, while at the same time introducing through careful thinking and thought-out architectural discussions, what should be new in that new architecture to help enable the cloud environment as well. So.
No, one thing I'd add to this is it's more than just taking something and making it at scale out. It's also reconsidering what we're doing. So if we take a packet as I described before, from the VM out of the building, you don't want to really be opening it up and doing stuff to it that many times. So if you rethink of it at a forest level, maybe there's a way to consolidate routing functions or consolidate firewall functions with routing functions, or consolidate load balancing or these types of things, NATing functions together into one thing, into a smaller footprint. So we have to, as is always the case, as we move through this world in an agile way, there's times when we iteratively keep adding, and there's times when we have to step back and refactor and simplify.
I'll take this one. So brownfield enablement, again, back to the physical VNFs to make their lives easier during the transition. So by nature, they're legacy in a lot of ways, and clearly they expect certain behaviors surrounding it. So you can't just expect something people or functions have been doing rather for the last 15 to 20 years and saying, cloudify it, right? So there's clearly some vendors out there who will, through business means, should be incentivized to rewrite, but at the same time, you want to make the transition easier, not only for your benefit to understand the challenges as a result, but also to evaluate certain types of functions and other options you have out in the industry. And some of the technologies that are being used to enable this brownfield migration of PNFs to VNFs in the Telco Cloud is, again, a lot of these PNFs for liveliness detection, which is essentially, how do I detect a certain node or a certain function is no longer functioning in a way that can provide the service? Mechanisms like ping, HTTP URI, level checks, BGP, BFD. These all, I don't want to get into details like Toby warned you with acronyms, but the net of that is these are mechanisms that all these VNFs are going to be wanting to use now. So you have to make that. You have to almost have a platform that enables that, or else the transition just won't happen to even get the ball rolling. Dynamic insertion of network reachability, that's a very long way of saying routing. There's clearly some requirements coming from VNFs, where they use routing as a mechanism to insert reachability for certain types of tunnels that they were facilitating, right? And it literally it's gotten to a point where you're saying, well, you don't have to do routing anymore, just use this API to insert reachability. They're like, well, I can't find the guy who wrote the app, or my vendor went out of business, so your platform needs to enable that for me. So that's kind of...
or the guys that made that whole thing are all dead.
That's a possibility, right? So, and then the 2 points I'll let Toby speak to, because I know it's...
Yeah, so I mentioned the live migration piece, and then another part that we're working hard on is rationalizing, okay, where are all these things going to go? Where does it make the most sense? And for us, it's been one thing I would like to impress upon everybody, for us, it's an opportunity to take something that had been very siloed. What DirecTV or Uverse was doing was very different than what voice was doing. So this brownfield that we work in, it's fraught with all kind of minefields, but it gives us an enormous opportunity to pull it together. And so one of the brownfield aspects that we have to solve for is how do we deal with the resiliency when the connection to your house is a single point of failure, or the central office is a single point of failure. We can't get away from, people don't really have the option to have connections to two places. So that limits, to some extent, our ability to do cloud-native mechanisms. As well, the other part that I want to press upon everyone is an opportunity for simplification, is that each of the PNFs, the physical network functions of the old days, came with their own orchestration tool. So there's a Nokia orchestration tool, there's a Cisco orchestration tool, there's a Ericsson orchestration tool, that, multiply that by 100. So one of the brownfield things that we're working on is how do I take all of those things and transition them to a more common approach. That's one of the things that we want to see the community do more of, is how can I take a Murano, a Mistral, Heat, and how can I take those OpenStack components and bring them together to make and solve for quite a lot of redundant effort. So this last piece I'll finish up with, left to our own, the natural path, I would have to attend 4 or 5 different standard boards, standard groups, efforts, ADIS, TM Forum, IETF, whatever, OASIS, DMTF. When the worlds of telco and IT collide, or those worlds collide, there are a lot of standards bodies, ETSI, so you have to go attend all those. And then now with the open source world, there's an ever burgeoning set of open source efforts that we go into. So like not only OpenStack, but Open Daylight and like Open Contrail. FDIO is coming. There's DPDK work, opening that up. There's Open Data Plane work. There's a lot of efforts. So this is one of the reasons why I'm so want to sell everyone on the concept of OPNFV. There needs to be someone somewhere that brings it all together and helps to coordinate the telco requirements and use cases and manifest that in something that can actually be used to test, are we going to actually achieve these requirements and be able to fill not only the functional ones but also the performance ones, as I described before. So in OPNFV, we're doing everything we possibly can to document and clearly enumerate what we're needing. And I urge everyone to look at it and then provide feedback where possible to tell us where we need to be better. Clearly, when we talk about networking, you can get lost in all of the acronyms and all the concepts, and we often lose sight of trying to make a much more simple description.
Sure. I mean, I guess the second one's obvious, documented, well, not entirely obvious, but documented APIs and data models. That's key, right? That literally gets everyone on the same. I kind of think of it like everyone can speak English, but everyone's still either grammatically incorrect or talking gibberish. You got to get everyone talking literally the same structured language. There's a lot of different efforts to do that. The world has kind of converged on certain data model representative type languages, but at the same time, that's all for naught if everyone doesn't agree on what all that means. So to Toby's point, there's 2 to the n exponential type operating system or orchestration tools out there. That's mainly because they all speak the language for their specific applications, or PNF/VNFs. I mean, taking again a PNF and putting in a VNF and still requiring your own orchestration tool is not going to work. I mean, that's not going to fly, right? The reality is everyone needs to come together in some of these initiatives to document common use cases for the telcos and get everyone on board. That's kind of my view.
Yeah, and then I'll close with just one last piece, is that one of the really great things about OpenStack is where there was not a storage standard for provisioning APIs, there is now one. Whether it wasn't for networking, there is now an enormous opportunity to make that happen. And so we're spending a lot of time working with the community to try to make this happen across many, many different domains. So I think that really concludes our content for right now. I wanted to save enough time for some questions. So
there was the future slide. I don't know if
you want to
go that. There was that one more.
Yeah. All right. Well, just in general, that as we talked about, it's more than just the things that are finding the right balance of hardware and software for simplifying, getting to common APIs. All of that is very helpful to fulfill the cloud requirements. But there's also, as I was getting at the beginning, we don't want to lose sight of, okay, that's all commoditizing what we do. How do we add value? How do we make this into a platform that can evolve faster? So one of the things, like what I'm working on lately, is adding storage to the story. How can I add storage to the central office to make it something that allows you to back up your mobile phone? How do I add more? How do I combine services together? How can I take maybe IBM's public cloud or Rackspace's public cloud and combine it together with our network and our capabilities to make a hybrid cloud that's compelling and bundled? These are things that I'm thinking about a lot lately, is how do we add more value on top of this set of the base requirements? How do we make more requirements that make us more valuable?
What he said.
All right. So if anyone has any questions, feel free to step up to the mic. And one last thing is, we made the guy stop crying.
Yes.
Thank you very much. Very interesting. Do you think that there is an eventual desired outcome where the telcos will want to use a carrier-neutral OpenStack cloud purpose-built for VNF, much like you see carrier-neutral facilities being used where they are able to gain connectivity to the last mile? Or do you think that AT&T and other telcos will want to continue to invest engineering resources to differentiate their own OpenStack cloud?
That's a very good question. I think, as I was kind of getting at with the bits, I mean, I think everyone here wants to see us find a way where all the telcos work together to make moving the bits cost less. And I was getting at a little bit last night in our time together with all the different telcos out at Stack City. You know, there is such an enormous opportunity to help get from the first billion people that have access to the next 5 billion or 6 billion people, and making this kind of technology available to a broader set of telcos, even the smaller ones. You know, that's what the TIP effort with Facebook's really working on right now, and I think that's quite exciting, and it kind of I think gets to some part of what you're saying, is that the carriers can work together to sort of make the bits less of important. But again, for us to continue to exist and be to grow, we have to find ways to add more value.
Thank you.
Anything I say will be considered bias. So.
Yeah, so a question, we're talking about the technical challenges on moving into NFV, and the question that I have is mostly on the moving to open source as a business model and the type of vendors that you expect will happen. This is definitely a disruption because the current model of in which a lot of the equipment and gears that you're using right now is being sold in appliances and very close kind of licenses model, and moving to open source is a completely different model. Do you expect that the new players that will come to that will be completely different than the incumbents that you're working with right now?
Absolutely. This is probably one of the more important points I wanted to make. As you've seen with Unix, just take Unix as a good AT&T example. I mean, for the longest time, people made when I started in IT, I used to pay $20,000 for a C compiler. That's a lot for something now that's very undifferentiated and essentially is everywhere. And then Red Hat and others have shown that it is possible to make a business out of taking something that eventually gets out to everyone and can add value themselves by adding services or support. I mean, for us, we have 50,000 Red Hat instances. So they provide a lot of value just by helping us keep those up and running. So there's always something for them to do. There's always something for people to add value on, even if the bits themselves are open sourced. Now, the part that I really want to compel everyone is right now, many of the VNFs, they aren't open source. Even with routing, it isn't really a meaningful open source router that I can use in the WAN. And we'd like to see that. We'd like to see that more with other components. And so I think you'll see that more, but it hasn't happened quite yet. So there is still a business to be had, and Red Hat has proven it, even if the bits change to open source.
So similarly, the question is to Juniper here.
Yeah, I mean, clearly we obviously are a company that has traditionally offered a certain set of product over the years. I've been a proponent internally saying, as the world shifts to open source and even open hardware, who knows this stuff better than us, especially in certain industries, right? So we can be the high-end services integrators for these types of services. Because look at Red Hat, right? They built a model around understanding and knowing Linux inside and out, right? But we have great guys, right? So to Boris's point, we have a lot of good ninjas, right? So it's just time to lease them out for hire, right? It's a different business model, and that's the biggest challenge for any public company, is trying to shift business models that way. But I think it's a necessity.
Yeah, and I also want to add, make sure everybody's clear on this. Open source is not free. It was never meant to be free. I'm a developer. I like developing, and at some point somebody needs to pay me. So even if I apply an open source license to it so that everyone can get enormous generative value out of it, still there's somebody who has to get paid for supporting it, and the ninjas got to get paid.
Thanks.
Hi. It was a very nice presentation. It's nice to see that there's a focus on the network, because what the reality is, network is our cloud, right? As good as your network, you provide better services. But unfortunately, from 1980s, 1990s, the network vision, I have private cloud, I have a private network, public network, and in the middle, DMZ. And the view is all these has the same DNA, same characteristics. Unfortunately, it's not true, right? So when you move into today's world, the front-end traffic versus back-end traffic, their DNAs are much different. So what's your vision to differentiate the back-end traffic by means of providing facilities, different views for better services for machine-to-machine, and to see better performance of the VNS? Thank you.
You can go for it.
No, you go. No, I go.
So I'm trying to understand the question. You're essentially asking how we see this telco cloud adopting to these different requirements that you're seeing from different applications, say on front end, back end. Oh, someone killed his mic.
What I'm asking, do you see a solution or features coming from OpenStack, for example, Neutron, to allow you the better features for the backend traffic to handle more traffic? Because the backend traffic is much
Yes.
ahead of the front-end traffic for machine-to-machine and health monitoring and stuff. With the e-com architecture of the AT&T, for example, there's a special framework called OMF and DCAE for analytics. This is whole backend traffic. So backend traffic versus front-end traffic, the ports on the front end not necessarily to be used on the backend, vice versa. So when you implement one security profile, it will not fly for you for a backend, for example.
Yeah, so I mean, this is a very good point, is like what we're trying to solve for is to solve this problem you're describing. I mean, and this overlays are one way to solve it, but I mean, and Neutron is certainly plays a key role in it. But this is why we want the network to switch to be more about software, so that we can provide QoS in certain areas and not in others. We can provide high throughput in some areas and not in others. We can do full packet inspection in some places and not in others. We want to judiciously apply these techniques to the problem so we can be more efficient. And software helps us to be that flexible, to do that in where and when we need that, where the hardware wasn't able to do that in the past.
So now that I understood the question, I think at the end of the day, at least us as Juniper, we obviously had a very conscious effort to make sure we addressed all these issues as much as possible on the back end, but at the same time be very conscious to contribute a lot of that to the community as much as possible. And that was the rationale for getting and putting Open Contrail out there, because there are a tremendous amount of requirements, and this stuff's moving very fast. I mean, it has to move fast, because I believe it's an existential threat to a lot of the telcos. So we're trying to keep the community open as much as possible by building essentially what I call the implementation on the back end for Neutron to address a lot of those use cases. And over time, as those start getting pulled back into Neutron in the community, we obviously make sure to adhere to all those APIs and data models as they get defined. And maybe at some point, some of these projects do become part of Neutron. That's, it's up for debate. It's not clearly in my hands to make that kind of decision, but that's. I don't know I think I answered your question in a different kind of way, but at the end of the day, it all depends on the implementation to address those use cases. And if you either wait on the community or execute on something you believe you need now, with the expectation that it'll eventually evolve and become part of a larger community effort. And that is our ultimate goal as well. That's why we open source it from day one.
And the beauty of OpenStack and the ability to bring new things in quickly.
Yep.
So you spoke about operators or vendors, sorry, not just porting their applications into a virtual machine and then call it cloud. You talked about how it should be native. Could you explain maybe some of the things that you'd like to see done on, maybe not at the firewall or NAT level, but more at the higher level applications like the MMEs, the HSS, the CSCS, these kinds of things? What, in your opinion, would mean that this application has been ported into cloud and it's native?
You want to say, right?
Like specific examples.
Yeah, absolutely. So one part is very clear, is that if I want to add more, if I'm getting more load in, that the way I add more capacity is by scaling up and adding more virtual machines or adding more containers, whatever it is, and scaling out that way. And I can do that infinitely. There's no stopping, there's no boundary. In the PNFs, there's always a boundary. So that's one part of it. And there's also the thing where with cloud native, you have an acceptance that resiliency of the 6.9's ilk or durability of the 16.9's ilk doesn't come from being in one place. It has to be able to be located in more than one, two, three places sometimes. And many of the VNFs aren't made to do that. And so some part of it is inherent to making a connection and keeping a voice call up and running, but we have to work through that and make it so that that can actually be serviced out of multiple locations to be able to maintain a high level of resiliency and a high level of durability. So I mean, that's one part of it that we're asking for, is having more flexibility to scale out. Another part of it too with cloud native is kind of working in an API model where you're allowing yourself to be just a module within a larger framework, and you're not thinking of yourself as the only thing, and then reusing other components where there's the possibility. The crying guy at the beginning is crying in part because he used to own the whole stack and he could control the whole thing himself. And that's also on our end, in our organization. We had teams that owned how I built the infrastructure and how I built the presentation layer and everything between. And they don't have that anymore. So going toward a more modular design is another characteristic that's unique to cloud native.
Yeah, I mean, that was probably going to be my key point, was modular design. I mean, I get there's a transition phase from going from a PNF to VNF, but if you look at certain applications, and in my mind, if it's already running on some form of appliance that's x86 based, it just happens to be in branded hardware for a certain vendor, that's ripe for moving it to a VNF, but then you have to really, really zoom into the application and the architecture this service is offering, and whether you can explode it out and really start rethinking how that fits into a larger framework. That's kind of what I meant by what I said earlier.
Right on. All right. Thank you, everybody, for showing up. And
thank you.